Let's continue on the accuracy fallacy introduced in the previous video. This ploy is to claim a system predicts accurately, thereby suggesting and reliably misleading the reader to believe that the system can distinguish between positive and negative cases and usually be right about it. But for many classification problems, that level of performance is only achieved in science fiction. The accuracy fallacy scheme is applied far and wide with overblown claims about machine learning accurately predicting psychosis, criminality, death, suicide, best-selling books, fraudulent dating profiles, banana crop diseases, and various medical conditions. This kind of trickery plays an integral part of the overhyping of AI in general by conveying unrealistic levels of performance. Researchers exploit and simultaneously feed into the population's misconceived fear of awesome yet fictional powers held by machine learning, commonly calling it artificial intelligence instead. Although I've found the issue is intuitively understood by many senior experts in machine learning, it isn't actually widely discussed. The problem with defaulting to accuracy as a measure is so fundamental to how we report on how well machine learning or any kind of automated classification works, and yet I just don't hear this topic being brought up. So I'm trying to change that, and it's me who coined the term accuracy fallacy. One more note before I delve into more examples. In case you're interested in more details about any of these examples or the points I make about them, you can access my article on the topic published by Scientific American, which has a lot of links. By the way, as I run through these examples and criticize how they misrepresent model performance, at the same time, this ironically serves as a nice survey of even more applications of machine learning in psychology, law enforcement, healthcare, and more. In many cases, they may have created a sound model that has real value. The only problem I'm addressing is how they misleadingly depict the predictive performance their models achieve. Machine learning algorithms can help psychologists predict, with 90% accuracy, the onset of psychosis by analyzing a patient's conversations. Thus opens an article in The Register of the UK eagerly covering an overzealous report out of Emory and Harvard universities, enshrined with the credibility of a publication in Nature. The researchers have the press believing their predictive model can confidently foretell who will develop psychosis and who won't. In this case, the researchers perpetrate a variation on the accuracy fallacy scheme. They report the classification accuracy you would get if half the cases were positive. That is, in a world in which 50% of the patients will eventually be diagnosed with psychosis. There's a word for measuring accuracy in this way: cheating. Mathematically, this usually inflates the reported accuracy a bit less than the pairing test, but it's fairly similar and it far overstates performance in much the same way. The Emory-Harvard report features a tantalizing 90% accuracy in its opening summary. What's the expected proportion that will develop psychosis? That is, how often is the predictive model expected to field positive cases in its intended deployment outside the lab? That fundamental is undisclosed. However, in trying to ascertain this, a persistent reader can chase citations and ultimately infer that the model is designed not for the general population, but rather only for patients who are help-seeking and therefore presumably at a somewhat higher risk. While the general population only exhibits a 3% rate of psychotic disorders, one of the data samples included in the study, that is the training data, exhibited a 23% rate. If that's the standard for this research work, it's still a good distance from the 50% positive rate over which they report performance. This accuracy level leaves readers believing. One commented online on a Psychology Today article covering this report, "If I observe this happening in somebody, can I be 90% sure that this person will, in close future, suffer a psychotic attack? And what shall I do in such a case?" As an aside, I'd be remiss not to mention that it turns out that their main result of 90% accuracy was established over a remarkably small number of cases, a sample of only 10 patients. Unfortunately, mental illness is tough to predict well, and machine learning is not on its way to solving psychiatry. This predictive model faces much the same limitations and trade-offs as the one that predicts sexual orientation. It will not be able to predict psychotic onset without incurring many false positives. And as before, accuracy isn't even a pertinent benchmark for judging predictive performance. The list goes on with many more examples of overblown claims about machine learning that perpetuate the accuracy fallacy. Criminality. The Global Times in China ran the headline, "Professor claims AI can spot criminals by looking at photos 90% of the time." Also reporting on this work, in which a model predicts criminality based on facial features, MIT Technology Review and The Telegraph in the UK each repeated the 90% accuracy claim. But the masses have been misled. Throughout their original publication, the researchers used accuracy to actually mean AUC. Death. One headline claimed, Google AI predicts hospital inpatient death risks with 95% accuracy. Google researchers published this result in Nature, leading the press astray by leaving it implied within the summary that AUC is a way to measure accuracy. Suicide. The press reported on a model that predicted suicide risk using electronic health records with 84 to 92% accuracy within 1 week of a suicide event. The Vanderbilt University researchers pulled the same maneuver as Google, leaving it implied within the summary of their research publication that AUC is equivalent to accuracy. Best-selling books. Beyond predicting the health and behavior of humans, machine learning predicts the sales of books. What if publishers could decide whether to greenlight each unpublished manuscript by knowing beforehand whether it would very likely go on to become a bestseller? Spoiler alert, they can't. However, in the book, The Bestseller Code, Anatomy of the Blockbuster Novel, the authors claim they've written an algorithm that can tell whether a manuscript will hit the New York Times bestseller list with 80% accuracy. As The Guardian in the UK put it. The Wall Street Journal and The Independent in the UK also reported this level of accuracy. However, the authors conveniently established this accuracy level over a manufactured test set of books that were half bestsellers and half not bestsellers. Since, in reality, only 1 in 200 of the books included in the study were destined to actually become bestsellers, it turns out that a manuscript predicted by the model as a future bestseller actually has less than a 2% probability of becoming one. The accuracy fallacy pervades, with researchers perpetuating it in the reports of these projects that you see listed. Legal applications, detecting fraud in online dating, spotting cyberbullies, many medical applications, etc., etc. Now, these are indeed interesting application areas of machine learning, and many of the projects are promising. For many of them, the only problem is in how they present the results, which greatly misleads how well their model actually predicts. The researchers seem to have caught a kind of greedy publicity bug when they went to write up the results. So many misleading reports, so much misleading of the press. This misuse of the word accuracy is crafty. So be sure to call it out when you observe it. Researchers dramatically misinform the public by erroneously using accuracy to mean AUC, or similarly, by reporting accuracy over an artificially balanced test bed that's half positive examples and half negative, without spelling out the severe limits of that performance measure right up front. The responsibility falls on the researchers to communicate unambiguously and unmisleadingly for journalists, and on machine learning practitioners to do the same for their colleagues.